Chapter 4, homework quiz. We'll work through this together, and there's 8 questions, and let's see how we do. Giving a test to a group of students, the grades and gender are summarized below. So we have our table here. And if one student was chosen at random, find the probability that the student was male. So probability male with nothing else given. There are 36 males out of 61 possibilities, so that's 36 out of 61. Give your answer as a fraction. And we could always test to see if it was reduced. 36 divided by 61. Notice it'll give us the fraction, it gives us a decimal, and since it doesn't give us a fraction, we know that it's reduced already. So go with 36. Use the fraction key out of 61. And we can do a little check here. They ask for a fraction, but then they give us this. I just imagine if you put in the decimal, you have to put it all in for it to be able to figure it right. But our fraction will do it. But that's a little frustrating. They say give a fraction, their answer is not a fraction. But we can see from here that their decimal expansion is the same thing we have over here. Okay. Question 2. Suppose a jar contains 17 red marbles and 10 blue marbles. If you reach in the jar and pull out 2 marbles at random, find the probability that both are red. Round your answer to 3 decimal places. Okay, so one more thing of this is there really is a first and a second. Even if you're grabbing 2 at the same time, one of them got touched a little bit sooner. So we got to think of it in terms of this. The first one, the probability of getting a red for the first marble is going to be 17 out of the total, which 17 plus 10 is 27. But when we go to touch the second one, and assume that, again, even if it happened simultaneously, we just say one was first. So now there are not 17 red ones because we've chosen one. We've got our hand on it. So there's only going to be 16 red ones. And there's no longer 27 total marbles. There are really only 26. So we multiply these out, and that's how we're going to get our answer. So 17 divided by 27 times 16 divided by 26 gives us this fraction. They wanted to, this time they wanted 3 decimal places, 0.387. 387. There we go. And again, we'll just do a quick check. 0.387. There we go. I guess we could submit these questions individually, and then that gives us a little bit better feeling, maybe, because we got our green. If you randomly select a card from a well-shuffled deck, standard deck of 52 cards, what is the probability that the card you select is a heart or an 8? So this is an or probability, right? And so remember, we have to add the 2 probabilities together and then subtract off any overlap. One way to do it. So how many hearts are in the deck of cards? Well, there are 13 of each suit, so 13 hearts out of 52 cards. How many 8s are there in a deck of 52 cards? There's 8. 8 heart or 8. But there is also a heart that is also an 8, the 8 of hearts. So we have to subtract that 1 card off. 13 plus 8 minus 1 is going to be 20 out of 52. Simplified fraction. So let's see how that works out. We'll put in 20 divided by 52. This would be 5/13. 5 divided by 13. Again, we can submit the question. It didn't like it. What did it not like? 4/13. Oh, that's 21, right? 13, 21. Oh, I'm going to keep going. I just recognize my error because this may be something you might do. There's 4 8s, but notice I put 8 instead of 4. So really, this is 13 out of 52. And I didn't even see that until I got the wrong answer. That's okay. 4 out of 52, not 8 out of 52. 8 is the number on the card, minus 1 out of 52. It's going to be 17 minus 1 is 16 out of 52. So when we put that in, 16 divided by 52, then we're going to get 4/13, not 5/13. Okay, and that's one of the reasons I give you multiple attempts at these. Let's change that to a 4, and then it's going to like it just fine. Because you don't get to see the answer, you would just get it wrong. You might not have recognized what you did. Obviously, I knew it was wrong, so I had to look. What did I do? There it is. Okay. All right. A test was given to a group of students. We're number 4 now. Let's move this up a little bit. The grades and gender are summarized below. So we've kind of seen this type of table before. One student is chosen at random from those who took the test. Find the probability that the student got a C given they are female. So this is the probability that they got a C given that they're female. Well, that they're female is, we know they're female, so what we're going to do is we're going to highlight the only things we need to consider now. Nothing else matters. They were female, so the males doesn't matter, these totals don't matter, just this is all the data we have. Now that she got a C would have been an 18 out of 34. So notice the total females are 34 and the C is 18. It doesn't say how to do it, but I assume a simplified fraction. So you could divide those both by 2, but I like with this NumWorks calculator, just 18 divided by 34, and we got 9/17. Oops, what did I do? 9 divided by 17. Okay. Let's submit the question, and we got it right. Okay. Number 5. How many different 3-card hands can be dealt from a deck of 52 cards? The order of the cards does not matter in this case. 3-card hands. 3-card. Oh, I was thinking of 3 hand. 3. Okay. I was thinking like poker, and there was 3 people playing poker. No, 3-card hands. What that means, now that I got my making sense, we're going to deal out 3 cards. The order doesn't matter, so it's not a permutation, it's a combination. So we want to think combination. Out of 52, we're going to deal 3. Order's not important. And obviously cards can't be repeated because once you deal it out, it's gone. 52, choose 3 is what we're going to need. So we come over to our calculator and we do our toolbox. It's this button here. It says paste on top. That little thing is actually a toolbox right next to the sort of delete key. And then we're going to come down and we are going to do some probability stuff. Look at all the stuff we can do. Probability, arrow over, we're going to do combinatorics. And this is the combination in over K. So we hit enter, we want 52, and we're going to choose 3 of them. 22,100. 22,100. Okay. Again, we could submit the question. You could also just check this answer here. That's good. But it all works out. So just using a combination. We could think of it with the list if it was a permutation. Giving a test to a group of students again, grades and gen are summarized below. If one student is chosen at random, find the probability that the student was male and got an A. Okay, now male and got an A. Now this is an and probability. And so what we want to do here, it was male and got an A. There's only 20 of those. Right? But it's just chosen at random. There's no given, there's no conditions. So it's all out of 62. Both things had to be required, both male and got an A. That's 20 of them. And it's out of the total of 62. Okay. Going to do in our calculator to get a simplified fraction. It doesn't say exactly how it wants it entered, but we'll put it in as a simplified fraction, 10/31. Okay, so that works. You see how that works from the table? Just how to satisfy both conditions. 5 different colored dice are rolled and the numbers shown are recorded. How many different outcomes are possible? So there's going to be, the way we want to think of this, even though order is not really important, we're just thinking of each die, each different color, right? So there are 5 different colors. 1, 2, 3, 4, 5. Each die can have 6 different options, 1 through 6, and we multiply them all together. This is not a permutation because they can be repeated, right? We could get all ones and such. And so it's 6 to the 5th power. 1, 2, 3, 4, 5. Probably the easiest way to calculate that. So 6 raised to the, oh, not answer, it's clear. I want to put 6 to the 5th power, not 5 to the 6. You gotta, because it's 6 is the number of different options. So we put in 7,776. And we go ahead and submit that. Yes, that is correct. Okay. And the last question, there are 14 children at a pirate-themed birthday party. You are going to draw 4 names from a hat. The first child whose name is drawn will play captain. The second will play first mate. The third will play navigator. And the fourth will play helmsman. So the order they're drawn in is important. How many possible results are there from this drawing? So since order is important because they're getting names, roles, it's a permutation. There's 14 children, and we're going to choose 4 of them. So it's a permutation of 4 items chosen from 14. And again, we can come over here to our toolbox. It goes to the combination, but we want a permutation. we want to permutate 14 items, we're going to take 4 at a time. And there's 24,000 different permutations for this particular party. That's a lot. So if you don't get the play captain, don't feel so bad. There's a lot of options where it doesn't happen. So just a simple permutation. All right, that is the homework quiz for chapter 4.